we go. And then we're going to turn on the record. All right, so this is going to be the main thing we honestly use dot products for, is finding the angle between vectors. So we've found angles of vectors. This is looking at the angle between two vectors. So what we do is we can find the cosine of that angle between if we have the dot product of the two vectors on the top, which is what we did yesterday, and we multiply both magnitudes on the bottom. So cosine of the angle between is the dot product and the product of the magnitudes. So what we're going to do to find the angles between is we're going to find dot product, magnitude of A, magnitude of B, and then we'll have to do an inverse cosine. So we're going to practice this. So write this formula down. Let me see if I have it on the next page just so I can change it. Hold on a second. And then we're going to get a couple of vectors and we're going to try this. We're going to find the angle between them. So I have that little formula up over here. So if you didn't get it finished down, it's up over here. There weren't tons of words with it. But we're going to look at vector u, which we have -5, -2. Vector v, which we have as 4, 4. And so what we want to do is we want to find the angle between them. So we need to find the dot product of u and v. We need to find the magnitude of u and the magnitude of v. Bless you. Bless you. So to find our dot product, that u dot v, that's what we did yesterday. That's when we take the x pieces and multiply them together, our y pieces and multiply them together, and then we add both those products. So we're going to have our -5 times the 4, and then we're going to add our -2 times the 4. So this was our x's and our y's. So our -5 times 4, that gives us -20. And we're going to add -2 times 4, which is -8. So our dot product of u dot v is -28. So then the other pieces we need is we need our magnitude of vector u. How do we find our magnitude again? Yep. The square root of the x squared plus the y squared. So we're going to have the square root of -5 squared plus our -2 squared. There's something I want to point out from going through the quizzes. Slow down on your squaring. I had a lot of people tell me 8 squared was 16 just because we were rushing. So slow down. I had a surprising number of people tell me 8 squared was 16. So if that happened to you, no, you were not alone. Slow down. We're getting the complicated stuff right and we're messing up on our simple arithmetic. Okay, so be careful, intentional, and slow down. Or if it wasn't that particular one, it was something of a very similar vibe. I have the quizzes. I have the front page entirely done. I'll get to the back page today, so I should be able to get them in today. I wound up having to leave early because I actually chipped a tooth in the middle of the day yesterday, so I went to an emergency dental appointment. So I did not get them finished. So when we do this, our -5 squared, we've got 25. And our -2 squared gives us a +4. Make sure we are thinking about those being in parentheses there. -2 squared is not -4. -2 squared is +4. So our magnitude of vector u is the square root of 29, which is not pleasant, but it's a thing. Oop. We also need our magnitude of v. I'm probably not going to write out near so many steps on this one. So same kind of vibe. We're going to take our 4 squared plus our 4 squared. And what are we going to have here? What's our magnitude for v? 32. Square root of 32. Which, if you want to simplify that and put it in simplified radical form, that's fine. We're going to be doing things with it. So honestly, I think leaving it unsimplified is easier to work with. But if it bothers you, there's no harm in it. So now what we're going to do is we're going to find the angle between these vectors. That means we're using this guy, our new guy. So what that tells me is we're going to have cosine of that angle. We're going to put that dot product on the top. We got dot product was negative 28. And our denominator, we have our magnitude of u, which was square root of 29, times the magnitude of v, square root of 32. We want to find theta. We want to find this angle. So you can simplify this. We can either type this thing in the calculator, we can multiply our radicands and simplify our radicals, or we can just hit inverse cosine and type this hot mess in. Because that's how we get to our theta, is we're going to do our inverse cosine, arc cosine, of this hot mess, negative 28 over square root of 29 times square root of 32. I'll say you could do 29 times 32. I don't know it off the top of my head. I didn't write that one. You could do square root of 928 if you really want to. Or you can put in your 29 times 32. Or you can write it like that. Either way is fine. But we're going to type it in the calculator. What do we get as our theta on this? 156.80. The angle between is 156.8 degrees. What this is, and this is not something you're going to be able to do, I'm just going to give you a visualization of what's happening here, is we have a vector that's our v, which goes to 4, 4, which looks here, and our negative 5, negative 2, which goes here-ish. And this angle is what we just found, our theta, is between them. Okay? Because what we had before is we could have found this angle, and we could have found this angle. This lets us do it all at the same time, without having to do it as 2 different angles and then subtract. But we're finding the angle between them. You are not going to need to draw this or graph this or anything. I'm just trying to give a mental picture of what the heck we just found. Instead of going, we found a thing that exists in the universe, and I don't know what it is. Okay? Questions on this one? We're going to do it again. Boop. Same vibe. We've got our 3, 1 as vector u. We've got 3, negative 3 as vector v. And we are asked to find the angle between. So start by finding our dot product. Find dot product of u dot v. That's what we did yesterday. What is our dot product of u and v? Yeah. There you go. It likes to make choices for me sometimes. I love it so much, so much. What do we get? Yeah, because we take our 2 x's and multiply them together. So 3 times 3, that'll give me 9. And we're going to add our 1 times negative 3, which is negative 3. So our dot product is 6. I would definitely count that as sufficient work too. So like you don't have to write tons of things. You don't have to write a gabillion steps. I would totally count that as having our work done and showing the work. How about our magnitude of u? Square root of 10. Because it's our 3 squared plus our 1 squared. 9 plus 1. How about magnitude of v?
3 square root of 2.
Yes, 3 square root of 2 or square root of 18, either way. And if you'd rather write it simplified, totally valid. Or if you do it in the calculator, it'll auto-simplify it for you. If you put the square root in. Okay, so then we're going to find our angle. Cosine of theta is, and we're going to put this in our fraction. Our dot product goes on top, the 6. And our denominator, we're going to have our square root of 10. And our square root of 18, or 3 root 2, however you wrote it. Don't matter to me. I like it better this way just because I can do 10 times 18 in my head, and 3 root 2 times root 10 is a little weird. But it's totally fine if you do it the other way. I just have a tendency to do this as our cosine of 6 over root 180. Just because it's easier to type in. So type it in. What do we get? What's our theta going to be?
76.
Well, let me check. That's not what I have, but I had to check. 180. But it's happened before where I'm off. It's not what I have. Let me see what. Yeah. Say that's what I have. I was like, I just like to double check myself before I automatically assume that you did something wrong, because it's entirely probable that I did something wrong. So we should have 63.4. Okay. So the calculation on these is not super awful. It's based off of things we've done. Questions on these guys? Well, it's been based off a whole lot of other things that were not near so easy. Okay. Really, the only way that these get any grosser is if they look like this. Don't freak out. I promise it's not that bad. Not imaginary. This is the unit vectors, where the I is my x's and the j is my y's. It's the unit vectors, not imaginary. Vectors do not exist in imaginary. So all we're gonna do when we see vectors written like this, rewrite them with the angled brackets. The I and the j, we talked about them a while ago, but I is just the vector that was 1, 0, so it's just x's, and j is the vector that's just y's, 0, 1. So what this is, if we have u with 2 i's and 4 j's, that just means it's got 2 x's and 4 y's. So if you see them written as a sum, that's all it is. It's your x's plus your y's. I's are the x's, j's are the y's.
Is it always going to be like that, or is there going to be different letters?
It would only be i's and j's. Because those are unit vectors, because who knows why they made those letters be it. Who knows? So what would v be as a angle vector? Negative 12, 6. Boop. So when we see them written as a sum, sometimes we get a little bit nervous, but it's definitely doable. So now what we need to do is we need to find our dot product. for U and V?
It's 0.
So if we do U dot V,
It's 0. Oh.
Oh,
No.
Negative 24. You got 0 as well?
mm-hmm. Yeah, because we wind up with negative 24 plus 24. So we get 0. What does that mean? Orthogonal, which means what? Perpendicular. So what's our angle? 90.
Oh.
It's orthogonal, which means perpendicular, which means our angle is 90. The reason this works is because if, no matter what my denominator is, if we have cosine of our angle equals 0 over some number, because these vectors aren't 0, so they're going to have something. It's inverse cosine of 0. Inverse cosine of 0 is 90 degrees. Okay, so no matter what our magnitudes are down here, we'd wind up with a 90-degree angle. So if we get something orthogonal, we don't have to do near so much work. Okay. Huh?
Are we done?
No.
No more story problems, right? Oh. Story problems? Why?
Because this comes from a physics thing.
Why are we doing physics?
So dot product is actually used in a thing for vectors. So it's a dot product. And pretty much the only thing that really matters with it is that we're doing the dot product and we're writing vectors and our units can be weird. Like foot-pounds or joules or newtons. Weird units. So it combines things together. So we're going to do 2 story problems. And I printed them because I'm nice.
Is that all we're doing?
Is it?
Okay.
These 2, and then we're done. Chapter done.
Wow.
Really?
When's the test? And then we have a review.
Monday.
Next Monday? Monday.
Monday.
Why Monday? Oh my goodness.
Because I didn't set the schedule.
Everyone's gonna fail if it's on a Monday.
What's up? I have the study guide. Oh, I should probably get the boxes out too, so y'all have scissors and glue.
I do the best.
I'll check.
Alright, so what we're gonna do is we're gonna start by trying to write vectors for the situations that you need to help to draw them. There we go. Scissors and glue sticks.
Mason is pushing you there. I forgot.
Okay, so we're gonna be looking at this one here.
What time is it?
Any orange blue sticks?
Yes, two. Yes. That one, the other one's done, just throw it away. All right. So we're gonna use the fact that that equation we just had on the last page, that was that work is the dot product of the force and the displacement, how much it moved. Distance is the units in the direction of the force. Force is how much we're pushing it. So we have Mason. So, ooh, here's Mason. I know, I'm so good at art. I have missed my calling. He's gonna push a vacuum cleaner. There we go. Vacuum cleaner. I know. I'm so good at drawing things. He's pushing it that way, because that's how you push a vacuum cleaner. With a force of 90 pounds. And the vacuum makes an angle. Oh, hang on. Different color. Angle of 63 degrees. The force he is pushing it is what we're looking at. So he's pushing at 90 pounds at this angle. So how can I write a vector that says we have 90 pounds with 63 degrees? The 90 is going to be which part of a vector? This is our magnitude. So we can write this as 90 cosine of that angle 63 and 90 sine of 63. But we need another thing to make a dot product with. We need the displacement. He's moving it 8 feet. So that means it's gone 8 feet that way. So he moved it 8 feet. So this displacement, that's again a magnitude. What angle did it move? 63 would be if I moved it up 63. It moved to 0. The angle is 0. Because it is moving. When I push the vacuum, another tiny vacuum. I didn't move it at an angle. I moved it straight across. I'm holding it at an angle. So if I hold my vacuum straight up, or if I drag it behind me, it's still moving at that angle of 0. It's just I'm holding the vacuum differently. So its displacement is still moving at 0. Okay? So if we write this as a vector, we're going to have our 8 cosine of 0, 8 sine of 0. So it kind of combines together the gross vectors with our dot product thing. We got to find our dot product. This guy is our force. This guy is the displacement, and we're trying to find the dot product, which tells us the amount of work. So that's when we multiply our x's together, we multiply our y's together, and we add them. So we're going to have our 90 cosine of 63 times 8 cosine of 0 plus 90 sine of 63 times 8 sine of 0. So our work is whatever, 90 cosine of 63 degrees and 8 cosine of 0. Cosine of 0 is 1. Sine of 0 is 0. So we're going to add 90 sine of 63 times 0, which means we're adding 0. So really all we need to do is 90 cosine of 63 times 8. So what do we get for our work? Type in 90 cosine of 63, close your parentheses, times 8.
326.87.
Not what I got, but could entirely be that I'm wrong.
I don't know.
Okay, then it's entirely probable that what I have in my book is wrong. It's happened before. So, yup. We're gonna go with that? Give me a second. 90 cosine 63 times 8. Yeah, I was gonna say 326.8. And what this is, as far as a unit goes, is we had that it moved in pounds and it moved in feet. So this is a unit called foot-pounds. Because physics is weird. Foot-pounds, that's it. That's our answer. It's the dot product. The hard part is the writing of the vectors. What's up?
What about sign? What are we gonna do anything?
What is sine of 0?
0. Well,
So 8 times sine of 0 would be 0. And then 90 sine of 63 times 0. 0.
Okay.
Okay? So yeah, the y piece all disappears because we get our 90 sine of 63 times 0. So that piece just straight up disappears. Okay? Very similar vibe on the next one. And that'll be the last one. All right, so now we got Kevin pulling his brother in a cart with a force of 40 pounds. The rope pulling the cart forms an angle of 27 degrees with the ground. And we're trying to figure out the amount of work if he pulls the cart for 30 feet. So, oh,
Yeah.
cool. I'll change mine then. I copied and pasted from the slide. How did it change? Love it. That's fun. Cool. Let me change it. I will match you because that makes way more sense than y'all matching me. So it forms a 62. Love that. I don't know how that's different. I straight up copy and pasted it from the slide deck. Fun times. All right, so again, we're gonna get some beautiful art. Here we've got Kevin. And we've got his wagon with his, little brother. So he's tiny. He's excited. There we go. Now he's in the wagon. He's standing in the wagon. It's very unsafe. But the rope that he's holding is... Okay, he's apparently standing significantly closer to the wagon, or he's very much taller. But that's okay. Okay. Hang on. I gotta make Kevin taller because this is way too small. So, hang on. Kevin. He's now got a tiny sibling. He's pulling a little sibling. I was just making it bigger because that angle was messing me up. There we go. Our angle is at 62 degrees. There we go. So the force with which Kevin is doing his work, how do we write that vector? 40 cosine of 62. And our 40 sine of 62. Okay. And the displacement, the amount he's moved is what? 30 cosine of 0.
is the displacement always 0 for the cosine?
No.
I was gonna say, more often than not, it's 0. It's honestly one of those things that we don't have tons of problems with it, but more often than not, it is 0. I can't think of a time when it wouldn't be, but I'm not willing to lock it in. 30 sine of 0. So then we're just finding our dot product. We've got our two pieces. So we're gonna get our work. Yes, and I genuinely don't have an answer because I did this with the wrong angle. What'd you get?
563.7.
That's what I got as well. 563.37. And it is, again, pounds and feet. So it's foot pounds, which is the most nonsensical unit of work. It makes, foot pounds is so weird. Because who the heck knows what a foot pound is? Okay. So dot products do have a reason to exist aside from finding angles, but for the most part, it's used to finding angles. Yeah. All right. So what I'm gonna pass out next. Chapter review. Okay. So this is the everything review. Okay. So I've got up here the stuff for the homework for 8-4, and you're getting your review right now. It's chunky as a review, but that's mostly so we have lots of practice. I know these are weird, and this includes our sines, our cosines, and the vector stuff. Okay, so we have lots of pieces on here.